Hello and welcome to today's lesson where we're going to look at calculating the speed of water ripples, which is part of the waves topic in GCSE Separate Science Physics. So in today's lesson, our aim is to work out an experiment to look at calculating the speed of water ripples, and so we're going to try to experimentally determine wave speed. So if we're successful and we learn in today's lesson, understand how to calculate wave speed, then calculate wave speed from experimental values and explain why different measurements are taken and how this takes place, which falls into the following part of the AQA Separate Science specification for physics, which falls into the waves topic of 4.6.1.2, properties of waves. In particular, describe a method to measure the speed of ripples on a water surface. So in our investigation today, we're going to try and calculate the wave speed of a water wave from measurements. So if you can find the wave speed of a water wave, you will have learned in this particular lesson. Now remember, the wave speed is the speed at which energy is transferred by a wave. It is also the distance travelled by each wave every second, which will be very important for this particular experiment. Now in the following investigation, as we're going to try and find the speed of ripples on a water surface, and we're going to try and relate this to the depth of the wave as well to see if that makes a difference. So you would need a tray, a stopwatch, a 30cm ruler and a 100cm ruler. Now the first thing you would do is use a ruler as a depth measure and place 25mm of water into a tray. You then place a marker pen underneath the tray as a ramp, remove the marker pen, which will cause the tray to fall and produce a wave, and then you'll measure the time it takes for this transverse wave to move from one side of the tray and then go back to it. Repeat that 3 times and generate an average, and repeat this investigation for depths of 20mm, 15mm, 10mm and 5mm. Measure the distance which the wave will travel and use this to calculate speed. So the first thing, like we said before, is we'd use a ruler to fill the tray to 25mm with the aid of a tap. Now the ruler has a systematic error of 5mm, meaning that when you place the ruler at the bottom of the tray, it doesn't start measuring straight away. There's a gap of 5mm before the ruler starts to take measurements. Now a systematic error is the constant error found on all experimental results. Now to remove a systematic error from your results, you've got to subtract that value from the result. So if our systematic error is 5mm, we'd subtract 5mm from all of these results. Now this type of systematic error is due to the measuring device not reading 0 when it should do. So that is called a zero error. Now you've got to include your 5mm zero error on the ruler in your values. So when you're taking your measurements, you would subtract, or in this case add 5mm to every measurement. Now also when you're doing this, you would ensure that the tray is flat when you are measuring the depth, as this can lead to an anomalous results. Now this error can vary with each measurement, unlike the systematic error. So that is a different type of error, and we call that a random error. Now in a systematic error, you would remove it by subtracting that value from all your measurements. You can't do that for a random error because that is a different value for each measurement. So to minimize a random error, what you do is you repeat the values and take a mean average. That's very, very important. Now the next thing is when you set up your water in your tray, you will place a marker pen underneath the tray to form a ramp. Now you'd ensure the tray is at the same angle each time. That is a control variable of the investigation. It has to be kept the same each time to ensure you will get valid data at the end of the investigation. You would remove the pen, and this will produce a water ripple on the water surface. Now that is a transverse wave. Water ripples are transverse waves, and this water ripple will transfer the energy along the surface to the other side of the tray. The wave will then reflect and go the other direction. Now note, the intensity of the water ripple will decrease. The amplitude will not be as high because some of the wave is absorbed by the tray. Now that's very, very important, because when a wave hits a surface, some energy is absorbed by the surface, some energy is transmitted through the surface, and some energy is reflected by the surface. So when a wave hits a surface, 3 things will occur. it will carry out absorption, transmission and reflection. So it's very important to note that the wave reflects one way, it hits off the surface and reflects the other way. So the distance travelled by the water ripple going from one side of the tray and back to the other side is going to be twice the length of the tray. So it's important to note that the speed of water ripples are actually slow enough to measure in the lab, unlike the speed of sound or the speed of a light wave. Both of those types of waves are just too fast to measure in the lab. Now we can measure the distance that wave travels with a ruler, like mentioned before, and we can measure the time they travel in the water with a stopwatch. We can then use these values to calculate speed with the equation speed is equal to distance over time, which is an equation you can use to calculate the speed of any object or wave at all. Now just remember, you will use a stopwatch or stop clock to time how long it takes the wave to go to one end of the tray and back to the other side. Now the reason why we are doing a reflection and measure when it comes back to the other side is because this increases the distance that the wave will travel and therefore the time taken of measurement, because it takes longer to go from one side and back as opposed to just one side. Now this will decrease the impact of error in your measurements. This is because the larger the measurement taken, the bigger the value you measure, the more accurate the measurement will be. This is because the error due to the experimenter, normally the reaction time of you pressing down on the stop clock, is a smaller percentage of the overall answer. Now the more advanced and sophisticated way of saying this is saying the larger the measurement, the smaller the percentage uncertainty. So it's your aim in an investigation to get the smallest percentage uncertainty possible. Now this is achieved by using the largest possible measurements of the values. Now you might say, why don't we let the wave reflect a couple of times and measure that distance because it's a bigger distance? In theory, we should do that. In theory, that will give us the most accurate measurement possible. However, as it reflects off the side each time, the wave will dissipate more energy out of it. It will be absorbed by the tray, and as a result, it will be very difficult to measure with the naked human eye. So we don't do it that way. Now, you would then repeat your investigation for depths of water of 5 millimeters, 10 millimeters, 15 millimeters, and 20 millimeters, and repeat your readings for each depth 3 times and calculate a mean average, as that will minimize your random errors. Now, remember, when you are measuring your distance, it's traveling there and back, so ensure your ruler is going to measure the length of the tray and it's perpendicular, but you'll measure there and you'll measure back because that is the distance the wave is traveling. You would then fill in your results table with your observations. Now please note, you would give all values in each column to the same number of decimal places, and the number of decimal places is decided by the resolution of your device you are measuring with. So for example, if your stopwatch measured to 2 decimal places, you would write your answer down to 2 decimal places. If your ruler measured to 3 decimal places, you would write the result down to 3 decimal places. Then you would draw a graph of your experimental results, placing the average speed on the y-axis and the depth on the x-axis, and draw a line of best fit as shown in the following. So what do we know? Wave speed does equal frequency times by wavelength, but it can also equal speed equals distance over time. You should be able to recall both equations and use them, and you should be able to describe a method to measure the speed of ripples on a water surface. So if you've been successful and you've learned in today's lesson, you can understand how to calculate wave speed. You can calculate wave speed from experimental values and take experimental values, and you can explain why these different measurements are taken and how this takes place in the lab. So I hope you've enjoyed today's lesson, looking at the investigation of how we measure the speed of water ripples. And we're going to, in the next lesson, look at how you can measure the speed of sound waves. Thank you very much and have a lovely day.